Hi students, in this video we will talk about the deductive proofs about angles related to lines and triangles. So in the element, actually Euclid already proved the following theorem. This theorem said that if the two adjacent angles are on a straight line, then these two angles, the sum will be 180 degrees. And this one we call it adjacent angles on straight line. And by using this adjacent angles on straight line, Euclid also proved that the theorem 9.2, that means if there are some angles, let's say A, B, C, are angles at the point, then the sum of these angles will equal to 360 degrees. And we can say that it is angles at the point. Angles at the point. And also, if there are two straight lines, let's say AB and CD, intersect at O in the figure, then the small letter A equals to small letter B, and also C equals to D. And this one we call it vertically opposite angles. Vertically opposite angles. So, and we also have some theorem. Let's look at this theorem. If we can say, we know that A plus B equals to 180 degrees, then this line AOC is a straight line. This time, this theorem, we call it adjacent angles supplementary. Because we know that the angles, the sum are 180 degrees, then we prove that the line is a straight line. It is a converse of theorem 9.1. So remember not to mix it up. So let's see how to prove it. Look at this question. This question, we had to prove that AOB is a straight line. First of all, we can write down the step of proof and then write down the reason on the right hand side. So first, we will say that the sum of these three angles will be 360 degrees, and the reason is angles at the point. Then, by calculation, we found x equals to 30 degrees. So we try to find angle AOB. It is originally 6x, so 6 times 30 degrees. We found that this angle is 180 degrees. Therefore, AOB is a straight line. The reason is adjacent angles supplementary. So don't write adjacent angles on straight line because you are using the angle equals to 180 degrees to prove this line is a straight line. So we need to identify the conditions carefully. So look at this question. We want to prove that AOC is a straight line. First of all, we will use the angles at the point to find y. Y, we found it as 12 degrees. And then we try to find angle AOC. Look at the right hand side. It is 132 degrees plus 4y. And we put y equals to 12 degrees inside this. And we found that it is equals to 100 degrees. Therefore, AOC is a straight line. And the reason is adjacent angles supplementary. Okay, and we need to use some theorem about parallel lines. Look at this. If we know that AB is parallel to CD, AB parallel to CD, then the angle A equals to B. The reason this is alternate angles AB parallel to CD, alternate angles AB parallel to CD. On the other way around, if we know that the two angles are equal, then two lines AB and CD will be parallel. And the reason this time is alternate angles equal. Alternate angles equal. Also, we know about this. This is corresponding angles. If we know that AB parallel to CD, then we say that C equals to D. These two angles will be the same. And the reason is corresponding angles AB parallel to CD. On the other way around, this time we know C equals to D. We know C equals to D. Then we say that AB parallel to CD. This is a converse of the theorem 9.7. So this time we will say that corresponding angles equal. We prove AB parallel to CD. Of course, we have interior angles. This time, if we know that the two lines are parallel, AB parallel to CD, then we can say that the interior angles, the sum will be 180 degrees. And the reason is interior angles AB parallel to CD. On the other way around, if we know that E plus F equals to 180 degrees, then we can say that these two lines are parallel. And the reason is interior angles supplementary. Interior angles supplementary. So let's look at some question here. This question, we know that F equals to G. We need to prove AB is parallel to CD. First of all, you can use vertically opposite angles to say that angle AFG equals to angle BFE. So this angle is F. And we know F equals to G. This is given. Then we know these two angles, angle AFG equals to angle CGH. Therefore, AB parallel to CD. The reason is corresponding angles equal. And maybe look at one more example here. So we want to prove AB parallel to CD. First of all, we can find that angle CGH by using adjacent angles on straight line because DGC is a straight line. We found this angle 110 degrees. And we say that this angle CGH and angle AFG, they are the same. They are all equal to 110 degrees. Therefore, AB parallel to CD. And reason is corresponding angles equal. How about this kind of figure? So you can also use some alternate angles. First of all, you find angle CDE, which equals to angle DEF, which equals to A, because alternate angles. And we know CD parallel to EF. And then we can say that the sum of these two angles, angle BCD and angle CDE, will equal to 180 degrees. This is interior angles because we have parallel lines CB parallel to DE. So A plus B will becomes 180 degrees. Of course, we will use some theorem, and these theorems will be very useful. What are they? Angle sum of triangle, and also the exterior angle of triangle. Why? Look at these examples. Look at this example. We want to prove AB parallel to CD. Look at the triangle CEF. We will use this triangle to use the exterior angle of triangle to find angle CEA, which is 65 degrees. And once we know these two angles, angle BAF and angle CEA, are all equal, we can say that these two lines are parallel. The reason is alternate angles equal. One more example here. We want to prove that AB parallel to CD. This time we use angle sum of triangle. Look at triangle CDE. We try to find angle CDE by using angle sum of triangle. And this one is 35 degrees. And once we know that these two angles are 35 degrees, we can say that these two lines are parallel. The reason is corresponding angles equal. So one more example here. Last example here, we first of all look at triangle CDE. We use the exterior angle of triangle so that we can find that angle CEDC, angle EDC will be 100 degrees minus B. And we look at another triangle, triangle BDF, and we add these two angles, that means D and 100 degrees minus B. We add them up, it becomes the exterior angle, that means 100 degrees. So after that, we can find that B equals to D. Okay, so please try your best to choose the best way to prove these kind of questions. See you next time.